Hi everybody, we are starting a new unit today, and the new unit is called Trig Expressions and Equations. Today we will be focusing on simplifying trig expressions, but before we can get into doing that, we need to recall a few things. And the first thing that we need to recall is that cosecant theta is 1 over sine of theta, and this you should know already. Secant of theta, we know, is 1 over cosine of theta. And cotangent, we know, is 1 over tangent of theta. Now, if we recall from the unit circle, we know that tangent of theta is sine over cosine, so sine theta over cosine theta. And cotangent theta is simply the reciprocal of tangent, so we just have to flip it. So that would be cosine of theta over sine of theta. All right. Now, all of these above identities, they can be squared, they can be cubed, etc. We can pretty much raise them to whatever power we want to, and you'll see later on what that means and how it comes into play. But now let's try a few examples. So example number 1, simplify the expression. So we have cosecant of theta times sine of theta. These little parentheses in between, that just means multiplication. So we're going to take cosecant, which is 1 over sine of theta, and we're going to multiply that, so go ahead and put the dot in, by sine of theta. Now, sine of theta is the same thing as saying sine theta over 1. Now, this should look familiar to you. This is from algebra. We have two fractions, and any top with any bottom can cancel. Anything divided by itself is 1, and the only thing we're left with is 1. Final answer. Okay, number 2. Secant squared of theta times cotangent squared of theta. This is what I meant before, that the identities can be squared and cubed and whatnot. So secant squared of theta is the same thing as saying 1 over cosine squared theta times cotangent squared of theta, which is cosine squared theta over sine squared theta. So again, any top with any bottom can cancel. So what are we left with? On top we're left with 1, and on bottom we're left with sine squared. So 1 over sine we know is cosecant. So since it's over sine squared, the answer should be cosecant squared of theta. Okay, number 3. We have 2 times secant of theta. So again, secant of theta is the same thing as saying 1 over cosine of theta, and 2 times that is just that. Now, 2 times this is, you could put this over 1, tops of tops, bottoms of bottoms. It's 2 over cosine of theta plus our tangent of theta. And tangent, we know, is sine of theta over cosine of theta. Okay, so when I have two fractions being added together, what do I know? I need a common denominator, which we have. So what do? We keep the bottom. And what do we do with the tops? We add them. Notice how I'm not adding 2 and sine of theta. They're unlike terms, so we can't add them. So we leave it like this. Okay, let's talk about number 4. Number 4, we're going to leave for a homework example. So before you come into class on Monday, I'd like that one to be done. It's a little tricky, but I think you can do it. All right, let's go to the next page. Okay, the next set of identities come from the Pythagorean identity. So, the picture that you see here to the left is a unit circle. And remember, in a unit circle, any point on the unit circle is cosine comma sine. If we drop down this perpendicular and we make a little triangle, we have x and y, which make up the legs of the right triangle, and 1, which is the hypotenuse. So if I wanted to write this in terms of sine and cosine, we would just simply say, using the Pythagorean theorem, that it's cosine squared of theta plus sine squared of theta equals 1, or 1 squared. A squared, cosine squared, plus b squared, sine squared, equals 1 squared, or 1. So this is our first Pythagorean identity. And if we wanted to, we could solve this equation here for, say, cosine squared. So this is going to be a variation. So if I wanted to solve for cosine squared, what would I do? Well, I need to get rid of this sine squared. How would I do that? Bring it over and subtract it. So cosine squared of theta is equal to 1 minus sine squared of theta. And what if I wanted to solve for sine squared? I got to get rid of the cosine squared. How do I do that? Subtract cosine on both sides. So again, sine squared theta would be equal to 1 minus cosine squared of theta. So this guy right here is our first Pythagorean identity, and the ones below it are variations of that Pythagorean identity. Okay, now there are two more identities that we can derive from this original cosine squared plus sine squared equals 1. And the way that we do that is we divide each piece of the equation first by cosine squared of theta. So let's go ahead and do that and see what we get. Okay, so cosine squared divided by cosine squared, we know that that's 1. And we know that sine squared divided by cosine squared is tangent squared. And we know that 1 divided by cosine is simply secant squared theta. So this guy right here is my second Pythagorean identity. And we can vary this a little bit, can't we? We can solve the equation for tangent squared. How would we do that? Get rid of this 1. So a variation would be tangent squared of theta equals secant squared of theta minus 1. Okay, let's find the other Pythagorean identity. So instead of dividing everything by cosine squared, we're going to divide everything by sine squared of theta. So let's go ahead and do that and see what happens. Okay, so we know that cosine squared divided by sine squared is cotangent squared. And we know that anything divided by itself is 1. And we know that 1 over sine squared is cosecant squared of theta. So this right here is the third Pythagorean identity. And we could vary this a little bit. We could solve for cotangent squared. How would we do that? Subtract 1 from both sides of the equation. So cotangent squared of theta is equal to cosecant squared of theta minus 1. Okay, let's review everything that we just said. So we said that we have Pythagorean identities. This one right up here, number 1, is the first Pythagorean identity. These two below it are simply variations. And now we have the second Pythagorean identity that we derive from dividing each piece by cosine squared. And we get this guy. Again, this is a variation. The third Pythagorean identity is found by dividing the original equation by sine squared. We did that here and we got this guy. That is my third Pythagorean identity with this as a variation. Okay, let's put it to use with some examples. Let's go to the next page. Okay, example number 1. We see here that we have 1 minus cosine squared times this. Some of you may be thinking that I could distribute this cosecant into it. I mean, you can do that and you'd still get the same answer, but let's try to pinpoint our Pythagorean identities or their variations. So I know that 1 minus cosine squared theta is a variation, and I know that that's equal to sine of squared of x, or theta in this case. And we're going to take this and multiply it by 1 over sine of x, because that's the same thing as cosecant. Now again, from algebra, we can divide any top with any bottom. And notice, sine squared x, that means there's 2 of them, so I crossed off the squared because there's only 1 left. And my final answer would be sine of x. Okay, example number 2. 1 minus cosine squared. This top piece, we know, is sine squared. We just did that in example 1. So sine squared x. And the bottom is secant squared minus 1, which is a variation, which is tangent squared of x. And now we can take the top and divide it by the bottom, which would be keep, change, flip. So let's take the sine squared of x and divide it by tangent. Well, what's tangent again? Tangent is sine squared over cosine squared. So now we can do our keep, our change, our flip. So we're going to keep the sine squared x divided by, that's the keep, the change, and the flip. What can I cancel? This with this, any top with any bottom, cancels to 1. The only thing I'm left with is cosine squared of x. Okay, example number 3. Cosine squared of theta, that's fine, we're going to leave that, nothing happens to that, plus, Well, let's simplify this. Cosine squared of x stays. Tangent, we know, is sine squared over cosine squared. So look, any top with any bottom cancel to 1. So I'm really taking cosine squared of x and adding it to sine squared of x, which we know is 1. Okay, example number 4. Example number 4 requires the use of double distribute. So let's go ahead and do that. 1 times 1 is 1. 1 times negative sine of theta is negative sine of theta. Sine theta times 1 is sine of theta. And sine of theta times negative sine of theta is negative sine theta squared. So what can we do? Well, these two can be canceled. And we're left with 1 minus sine squared of theta, which is a variation, and the answer is cosine squared. Okay. Moving on. Example 5 and 6. I think these are good for a homework assignment. So why don't you try to do questions 5 and 6 and bring them into class tomorrow, and we will go over it. Okay, we're all done.